last page. So determine vertical, horizontal, and oblique asymptotes. And again, horizontal and oblique, that's going to be OR. So here's our function, and we want to make sure that we don't have any holes. So we want to first factor our numerator and denominator. So I'm going to pull out a 3, so I'm left with x minus 2 over, this is our difference of squares, so it's going to turn into x plus 2, x minus 2. Okay, so if we're looking at our vertical asymptotes and our holes, the first thing we actually want to do is see, can we cancel anything out? And if you take a look, we have x minus 2 and x minus 2, so those are actually going to cancel out and go away, which tells us we have a hole at x minus 2, which equals a hole at x equals 0. Okay, so then we want to look at our vertical asymptote, and that's going to be where we set our denominator equal to 0. So I'm going to use the factors that we broke up, so we have x plus 2 and x minus 2. Set those equal to 0 and solve, so there's going to be an asymptote at x equals negative 2 and a positive 2. Vertical asymptotes. Okay, and our horizontal asymptotes or oblique is where we need to use our long division and divide. So we have 3x minus 6 divided by x squared minus 4. And in this case, we want to see where this term out here can turn into this first term. But if you notice, this degree is higher than this degree. So this is the case where y equals 0. And I'll explain why. If the degree is higher in the denominator than the degree in the numerator, this actually would have to be a placeholder that we'd put in. So we have 0x squared plus 3x minus 6, because these have to at least match up. So if x squared wants to become 0x squared, that's where we have to multiply it by 0. And once we get our constant, we're good to go, so y equals 0, which is horizontal. Okay, so we're going to move on to number 7. Let's just factor this, make sure there are not any holes. I'm going to just change again real quick. Okay, so if I factor this function now here, this is a difference of squares, because we can take the square root of 4x squared and we'll get a 2x, and then plus 1, and 2x minus 1. And if we factor this, we can take an x out of our denominator, so we're left with x plus 3. Okay, so there's nothing that can cancel, so we have no holes, but our vertical asymptotes is where we're going to set these equal to 0, this equal to 0, and this equal to 0. So vertical asymptotes are at x equals 0 and negative 3. And then horizontal or oblique, again, we want to set up our long division. So we have 4x squared minus 1 divided by x squared plus 3x. So x squared, we're good to go there, but we need this to turn into 4x, so we'd have to multiply it by 4. And again, we can stop once we have our constant, because we don't really care about the remainder. So since y equals 4 is a constant number, we know that that's a horizontal asymptote. So now we're going to put this all together into a graph. So in order to sketch this out, we want to find vertical asymptotes, horizontal, see if there's any crossing happening, find our x and y intercepts, and then make sure we understand how to form this graph. So to find vertical asymptotes, we want to factor this out, make sure there are no holes, and see if we're left over with what we're left over with in the denominator. So I'm going to change my color again real fast. We're going to factor this. So both of these are difference of squares. So I have x plus 1, x minus 1 over x plus 2 and x minus 2. And you'll see that we can't cancel anything out. So we have no holes, but we are going to have some asymptotes. So we're going to take our denominator and set it equal to 0 to solve for our vertical asymptotes. So x equals a -2 and a +2. All right, bear with me on these because it's a little difficult to draw these straight lines on this Mimeo. And here's our +2. Remember, we can never ever cross these, but we could possibly cross our next asymptotes that we're going to find. All right, so let's divide these. We have x² -4 divided by x², hold on, x² -1, numerator, divided by x² -4. So this needs to turn into this, which is a 1, so y equals 1 is our horizontal. So here's y equals 1. All right, now we want to determine if there's any crossing at all. So here's where we want to take our horizontal or oblique, whatever it was, but we're going to take this asymptote and we're going to set it equal to this function. So this 1 is going to be replaced for r of x, which is also a y. So 1 equals x² -1 over x² -4. And in order to solve for the wholes, we want to cross multiply or just multiply the denominator to cancel it out. -4 on both sides. So these go away, and now I'm left with up here. We distribute our 1 in here, so we'd be left with x² -4 equals x² -1. We got x² on both sides, so they go away. So I'm really left with -4 equals -1, which is false. So that's telling me there's absolutely no crossing. No crossing at all. So I cannot cross this at all. So that means I'm going to have a section drawn up here or down here. Something will be drawn up here or down here, up here or down here. So this is where we get to choose some points to help us out. And the best thing to do would be choose our intercepts. See if we have any x or y intercepts to start us off. All right, so find our x-intercept. That's where y becomes 0, so we're going to set 0 as our y function. And really, for our x-intercept, we just have to set the denominator equal to, or the numerator equal to 0, because our denominator will cancel out. So here, this is going to tell me, we can already look, we factored it up here, that we will have an intercept at x equals -1 and a +1. So our intercepts are -1, 0 and +1, 0. So we can plot those. All right, now I want to see if we have any intercepts on our y. So our y-intercepts, we're going to find y and set x equal to 0. So we have 0 -1 over 0 -4, which gives us a +1/4. So 0, here's about 1/4. There's our y-intercept. So I definitely know there's no crossing at all. So this graph is going to want to hug this asymptote and this one. So it's going to come up, go through all 3 of these points graphed, and go down and come really close. So there's this section. Now I want to figure out what's going on back here and over here. So a really great point to choose would be -3, because it's real close to the asymptote. So another point I'm going to choose is going to be -3. So r of -3, I'm plugging in -3 to all my x values. So -3 squared is 9 -1 over 9 -4. So we're left with 8 over 5, which is a little bit over 2. So -3, I'm going to go up to a little bit over 2. And that's going to also tell me I know I can't cross at all. So I always want to hug these asymptotes, get really close to it. So this is going to get really close to this one, go through this point, and go up, up, up really close. So now I got to just figure out this section, and I am going to choose a positive 3 and see what happens. So as I choose a positive 3, I'm plugging 3 into all my x values. So 3 squared is 9, minus 1. 3 squared is again 9 minus 4. So same thing. So again, if we want to look at the points, it's 3 8/5, negative 3 8/5. So here's my positive 1, 2, 3, and I'm back up again a little bit over 2. And there's no crossing, so I got to get close, go through, get close. And there's my final graph.